Hey JSworld, my name is Daria Caraway. Thanks for coming to my talk on building Considerate React component APIs with TypeScript. I am a software engineer at Workday in Colorado in the United States. I work with React and TypeScript every day. If you have any questions or you just want to connect, feel free to find me on Twitter at Daria Caraway. So today I want to talk to you about a concept that I call Considerate React Component APIs. And to help me explain this concept, I want to introduce you to a company that I completely made up for this talk, BarkPark. BarkPark is like a social media app, but for your pets, to help you find playdates with pets in your area for your pets. Now, BarkPark has a product MVP that's just a wireframe at this point, and the wireframe looks like this. So ideally, there's going to be this explore page where you can thumbs up or thumbs down pets in your area that you think may or may not be a good match for your pet. If you get a playdate match, you'll see a notification up here in the header. And you can also go to your pet's profile and edit what people see about them. So there are some things here like their name, their age, you can change their photo, and this is just the profile that other pet owners will see about your pet. But right now, the edit profile page in development actually looks like this. So there's a couple of bugs and it's all around just not looking as good as the one in the wireframe. So BarkPark is going to try to be fixing this up. I also want to introduce you to Lisa. We're all going to go on an adventure with Lisa today. Lisa is a new hire at BarkPark. She's starting a new role on the web app team, so she's going to be responsible for helping build out the real version of that wireframe. Lisa is a JavaScript developer. She's never worked with TypeScript. Right now, I hear that BarkPark is using JavaScript, but there have been talks that they might want to move to TypeScript. Today is Lisa's first day, and she's gotten acquainted with the company. She's gotten acquainted with that prototype I showed off. So she decides to dive in and pick up her first ticket to start onboarding. In this ticket, the card contents of the edit profile card are switched. The body is rendering in the header and the header in the body. So this big chunk of text is supposed to be on the bottom, and my pet's name, Mia, is supposed to be up top in the header. First thing Lisa does is go to try to figure out where this card component is being used. So here I have a little bit of the React component that is the edit profile page, and this is where the card component is being consumed. And you can see that the card takes a couple of properties, and immediately Lisa is a little bit confused because card takes input 1 and input 2, but based on the name of these properties, you're not really sure what input 1 and input 2 is supposed to be. So to find out, Lisa has to dig in a little bit deeper to look at the card component implementation. In the card component implementation, there's some hidden context in here that wasn't immediately available by looking at just the properties, which is that input 1 is supposed to be the header text and input 2 is supposed to be the body text. But in the edit profile page where the card was being used, those props were getting passed in backwards, hence the bug. With this knowledge, Lisa goes to open up her first pull request or PR in the BarkPark repo. And instead of just flipping the props and fixing the bug, Lisa decides to make the component API a little bit more clear for the next person, so they won't also have to go and figure out what input 1 and input 2 are supposed to mean. So she changes input 1 to be header text and input 2 to be body text, so it's a little bit more explicit. And she takes that context that was hidden in the card component implementation, she hoists it up and bakes it straight into the card component API, so it's a little bit easier to find. And here Lisa is demonstrating exactly what I call a Considerate React component API, which is all about just giving as much upfront context as possible to the next person who's going to have to interact with the component, because you don't want to make them guess your intention or dig for more context when they're coming in a little bit later and they might not have all the knowledge that you have on the subject. With this PR, Lisa gets that merged and the card component bug has now been fixed, which is awesome. Now Lisa's gotten a little bit more familiar with the code, so she goes to pick up her next ticket. In this ticket, it turns out the BarkPark team has decided to convert their app to TypeScript. They figure that the app is still pretty small and they want to convert it before it gets too big and the project gets to be too much time. So in this ticket, Lisa's responsible for updating the select component in the edit profile page to TypeScript with proper types. But like I said earlier, Lisa doesn't have a lot of experience with TypeScript, and so she wants to do a little bit of research to figure out what's the best way to use it, why are you trying to use it, and really figure out what is meant by proper types. Now, the first question Lisa wants to figure out is, what is TypeScript? What even is it? She learns that TypeScript is a typed superset of JavaScript, which means that it offers compile time type checking, and it also compiles down into JavaScript that can be interpreted by a JavaScript interpreter. The other question Lisa wants to know is, why would you use TypeScript? Why does anyone use TypeScript? And how are you really supposed to take advantage of it? Now, the usual reason that I see for why you should use TypeScript is that it offers static code type checking. So you can add types to your JavaScript code, and these types can help catch bugs during compile time instead of runtime, which means that you catch a certain class of bugs when you compile your code instead of when your users are going to run your code, which is pretty nice. And the real kind of magic of TypeScript really all sits in the TypeScript compiler. So the TypeScript compiler is responsible for two things. In one process, it takes all of your TypeScript, it transforms that code, and outputs JavaScript that, again, can be interpreted by a JavaScript interpreter. In a separate process, TypeScript will come into the TypeScript compiler, and the TypeScript compiler will start type checking against your code. And the really important thing to know about the TypeScript compiler is that these two processes happen completely independently of each other, which means that unlike other traditionally statically typed languages like a C++ or a Java, TypeScript types don't affect the converted JavaScript code in any way, which means that types don't really help inform the compiler like they might in C++. And types don't help the browser in any way because the types never even make it to the browser. The browser only receives JavaScript. TypeScript types exclusively help people. And that's why one of my favorite reasons why I like to use TypeScript is because TypeScript is a phenomenal communication tool. TypeScript is a tool for people, and TypeScript allows developers to add more upfront context directly into their code. And this is why I think TypeScript is the perfect tool for writing more considerate React component APIs. Taking all of this that Lisa's learned about TypeScript, she goes back to her ticket to convert the select component to TypeScript. First thing she does, she goes to take a look at the select component API and the select component to figure out what all are the things that she's going to need to type. She finds out that the select component has a couple of props. It takes options, selected value, and an onSelect callback. With the information that she found looking at the JavaScript code, Lisa goes to open up another PR in the Bark Park repo. Here, she types the select component. She types the options as an array of any, a selected value as any, the onSelect callback as a function. And technically, the file was a JavaScript file, and now it's a TypeScript file. All of the select pieces have types on them, and the code compiles, and it runs, and it works. So theoretically, this component has been successfully converted to TypeScript. But Lisa had some trouble with that last component API with the card that she was trying to use. So she wants to make sure to test out her component API like a consumer. So the next person that comes in has all of the information that they might need. Testing out your API like a consumer is all about just checking to see if your types are considerate. Putting aside any implicit knowledge you have of the subject, of the component, of the code, what are your TypeScript types trying to communicate? And going back to Lisa's PR with the select props, she realizes that her TypeScript types, they're not communicating all that much. They're really not adding too much additional value from the original JavaScript code. Because if you were to go and use the select component and you needed to pass in options, you know that it's an array maybe, but you'd still have to dig into the code to figure out what the options are actually supposed to look like. If you were to dig into the select component code, you would find that hidden context, which is that options are objects that are supposed to contain a label and a value. And the callback, when a select option is selected, the callback will give you back the value of the option that was selected. Taking all of this information, Lisa tries a second time to type the select component. She updates the options to be an array of select options. In this case, select options are an object with a value and a label. She types the selected value as a string because this select component is dealing with strings. And the onSelect is now explicitly a function that takes in a value and returns nothing. So once again, Lisa takes that context that was hidden in the select component and bakes it straight into the React component API, so it's even more upfront for consumers of the select component. And here, Lisa learned something that I think is really important about TypeScript, which is that compiling types are not always helpful. Because in TypeScript, types can be as loose or as strict as you want them to be. So it's really up to the developer to think like a consumer and figure out how to bring the most value with your TypeScript types. Okay, Lisa is starting to get the hang of it. She's done a couple of tickets at this point, and she thinks she's ready to pick up another one. In this ticket, the design team wants all of the buttons on the page to be a uniform, larger size. So right now, they're this kind of like really hard to see and click on small size. Lisa needs to update these buttons to the medium size. Again, first thing, Lisa goes to look at the button component to figure out how is she supposed to change the size of this component. And she sees that the button does take in a size, which is typed as a string. But this is a little bit confusing because just looking off of this type, you're not sure what that string is supposed to be. Like, are you supposed to pass in a CSS string like 12px? Are you supposed to pass in the letter S or the word small? It's not super clear. So to find out how to use this button, you have to go and figure out what that size is supposed to be. And in the button component lies that hidden context, which is that sizes and also the variant of the button, they're predefined strings that map to CSS. So if you pass in the word small, the button will apply the small CSS. If you pass in the word medium, the button will apply the medium CSS. So Lisa thinks that she can add some context into the React component API with this knowledge to make it more readable for the next person. And she decides to do this with a string literal union type. Now, string literal unions are really, really handy types. They give you enum-like behavior, but for strings. So in this case, now the button component will only accept the size property that is small, medium, or large. If you try to pass in a string that isn't one of these three, the TypeScript compiler will tell you that that's not a valid option. Whereas before, you could pass in whatever string you wanted, and maybe you'd get a runtime error because that string wasn't applicable for the component. Taking this, Lisa thinks this string literal union is pretty great, so she opens up another pull request, and she changes the size and variant of the button props from string to the string literal unions. Once again, she's taking that context that was hidden inside of the button component and bakes it straight into the React component API. But Lisa, again, she wants to test out this like a consumer because she knows that these string literal unions add a bit more context, but if you still have to go and find them, maybe they're in a different file, maybe it's not too straightforward where they are, that can still be a little bit confusing. But when Lisa goes to uptake the button to change it from small to medium, she sees that this wasn't happening before, but now her IDE is auto-completing all of the options for her. And this is just another way to bake in context directly for your consumers, even higher than inside of the code itself. And this is cool because autocomplete or IntelliSense, whatever you call it, are other tools and components that consumers interact with when they're using your components. And this reveals a little bit of something, which is that there are a couple of different aspects to being a consumer, and that TypeScript types can be a useful communication tool outside of just like reading the code itself. So if you think of all of the ways that you interact with a React component, it's possible that TypeScript can help provide context in several of these different interactions. As soon as Lisa's PR goes in for the buttons, the page no longer has these small, weird buttons, but the buttons are a little bit bigger and a little bit more usable. So we're getting one step closer. And now Lisa is officially the button expert on her team because nobody else has done anything with the buttons. So they decide that she gets another button ticket. In this ticket, the core component team has created a new button that all the other teams, including Lisa's, they need to uptake it. So Lisa needs to convert all of the buttons on the edit profile page to the new awesome button, which is just styled much more nicely than the old button. The good news for Lisa is that someone on her team already converted one of the buttons to an awesome button. So you'll notice the save button in the corner is already like a nicely styled awesome button. So Lisa can go and look at this for a reference point to see how she's supposed to convert the button to an awesome button. And she sees this awesome button and it looks like it has the same API as the old button. It takes a size, a variant, an on-click callback, and a child, which is the button text. So seems really, really easy. She goes to open up another pull request and she updates all of the buttons to be the awesome button. Simple as that. But when Lisa goes to test out her change, she realizes that now all of the buttons on the page are really big. It looks like they're all size large, but we know that Lisa just changed the middle buttons to be a size medium. So she's not really sure why, when we're passing in medium, the buttons are showing up as large. And she has to go and figure out why this is happening. So she goes to look at the awesome button code and she sees that it's pretty clear that the size property, it's not being used. The awesome button is hard coding the size style to size large. Presumably someone wanted to unify all of the sizes to a single size. But that's really confusing because if you take a look at the awesome button component API, it looks like it extends the button, the old button props, and it takes a size. So that's a little bit misleading because it seems like the size isn't doing anything. And if you take a closer look, the awesome button props are actually extending partial of button props, which is a little bit suspicious. So the partial type, it takes all of the properties of the type that you give it, in this case button props, and it sets them all to optional. So it's basically saying the awesome button props is the same as button props, but the size, variant, on-click, and children are optional. And it's possible that someone was trying to add some sort of context here. It's possible that someone was trying to say, hey, the awesome button props, it has all the same props as button props, except like not all of them, and that's why it's partial. So you're only supposed to pass in some of them, but it doesn't tell you which ones you're supposed to pass in. And the hidden context here is that awesome button props is supposed to accept all of the props as button props, except size. So to make that a little bit more clear, Lisa thinks she can swap the partial type for the omit type. The omit type is really handy. It constructs a new type with all of the keys or properties of the provided type, minus any ones you tell it to omit. So in this case, awesome button props is going to have all of the same props as button props, except size. And if you try to pass in a size, the TypeScript compiler will tell you like, hey, the awesome button props, it doesn't need your size. You're not supposed to pass it in. And that's a good indicator to the consumer that the awesome button isn't going to have variable sizes like the old button did. So in Lisa's PR, she changes the partial type to the omit type. And once again, she takes that context that was hidden in the awesome button component and bakes it straight into the API to make it more understandable for the next person. And here is something that I think is one of the bigger drawbacks of TypeScript, which is that in TypeScript, incorrect or misleading types can often be worse than no types. Because if you think about it, like the types are providing you some sort of information or context, like I've been talking about, you start going down one road assuming this context is correct, and then it turns out not to be. And now you've gone down this road and maybe it's wrong, and that can cost you time, it can lead to bugs, and it can be kind of frustrating. So just like it's up to the devs to make sure that you're bringing value with your TypeScript types, it's also up to the devs to make sure that types are accurate and up to date and continuing to add positive context. Great. So Lisa also has a conversation with the designers and she's like, hey, I think maybe the large button is just too big for this page. So they agree that the awesome button should be a size medium across the board, and the page is starting to look a lot better. Okay, so the team is starting to get pretty close to having successfully implemented the wireframe, but there's a couple more things that they need to do. So users also want the ability to display the age of their pet. And to do this, Lisa needs to update the select component so that it can take numbers and not just strings. Because right now in the select component, Lisa finds the code that she had written, which is that the select component is only accepting a value of a string and is expecting like all of the selected value and onSelect values to also be strings. Now, Lisa knows that the actual select code down below, it doesn't really care what type your thing is because it's using like indexes to figure out what you've selected. It's just the TypeScript types here that are preventing you from passing in a number because it says that it only accepts a string. So Lisa thinks she can update this by using a union type. A union type composes a type from the union of two or more types. So in this case, Lisa's saying that, hey, the options for the select can either be a string or a number. And the selected value can also be a string or a number, and the onSelect callback will give you back a string or a number, which sounds pretty good because the ticket asked Lisa to update the select to handle a string or a number. So Lisa goes to open up another pull request with these changes, and she updates the value and the selected value in the onSelect of the select option from a string to be string union number. But starting to think like a consumer, Lisa thinks that this might be a little bit misleading because according to these types, if you pass in select options that have values that are strings, according to these types, you could still get back a string or a number in the onSelect callback, which is not necessarily true because there's some hidden context here in the component, which is that if you give the select a string value, you will get back that same string value in the onSelect callback. At no point can you give the select component strings and get back numbers in the onSelect callback, or you also can't give it numbers and sometimes get back strings or numbers in the onSelect. You'll always get back the same type of whatever you put in. So Lisa thinks she can add some more context here by changing the union type to a generic type. Now, generic types I think can be a little bit confusing, but essentially what's happening here is a generic type T, it just represents a type that the consumer is going to have to provide. And TypeScript will make sure that whatever type the consumer provides, it guarantees and it enforces that all of the type T's here are of that type. So if you tell TypeScript like, hey, I'm making this select a number select, TypeScript will enforce that all of the type T's in these types here are in fact numbers. And if that isn't the case, it'll throw you an error. On the flip side, if you tell TypeScript, hey, this is a string select, if you pass in a string for the value and you tell it it's a string select, it'll make sure that all of the type T's here you've also said are going to be strings. And this is really great because once again, Lisa can take that context that was hidden in the select component with the unions and bake it straight into the select component API itself. Now, the other really great thing about using generics here is that if you were to want to use the select for something else that wasn't a string or a number, if you were going down the union path, you would have to keep unioning on other types to make the select component work for those types. So if you wanted a select component that handled Booleans, you would have to do like string union number union Boolean. And that is a code change when you're not really changing the behavior. With the generic, you can just say like, hey, I want this select to be of type Boolean, and TypeScript will just make sure that you're following all of the rules here for supplying correct Boolean types to the rest of the properties. Okay, wow. So at this point, we've used any type, function type, string literal union type, partial type, omit type, generic type, and like it's starting to look as if TypeScript just has a lot of types. which is true because TypeScript has so many types and so many additional features, and the team is always releasing more. And I really love this because it means that it's becoming easier and easier to take the context that you have in your head and bake it directly into the code. It can take practice, but there's almost always a way to write considerate types with TypeScript. And sometimes if I find myself struggling to figure out what the correct typings are and it's not super clear, sometimes it's a sign to me that whatever I'm doing is a little bit confusing and it's probably not going to be well communicated to the next person. So TypeScript can also provide hints there that maybe whatever logic you're trying to type, if it's really difficult, maybe there's another way to make it a little bit more easier to understand. With this PR of adding the age select, the BarkPark team has now successfully implemented the wireframe in reality, which is awesome. But more importantly, I think Lisa's team really likes her. Remember, she was new when all of this started. And it's because Lisa takes advantage of TypeScript as a communication tool to write more considerate component APIs, which means that Lisa's code is easier to reason about, maintain, refactor, debug, and what more could you want from a new developer starting on your team? So, why should you use TypeScript? Why would you want to use TypeScript? Most people will tell you it's that TypeScript offers really great static code type checking. So you can add types to your JavaScript, and these types can help catch bugs during compile time instead of runtime. And this is a really good reason to use TypeScript. But apart from that, one of my favorite reasons to use TypeScript is just that it's such a good communication tool because you can add some types, and these types are a way to provide additional context and communicate additional intent directly in your code and in the tools that we already use and have to keep up to date anyway. So next time you're writing a TypeScript React component API, or maybe you don't use React and maybe you're writing an Angular component API, maybe you're writing the API for an API in Node. Maybe you're just writing a function signature. Whatever it is, I hope that you take a step back, test out your types like a consumer, and consider using TypeScript to help make your React component API, your Angular component API, your Node API, whatever it is, a little bit more considerate. Thank you so much, JSworld. I hope you have a phenomenal time at the rest of this conference, and I hope to see some of you all online. As always, you can find me on Twitter at Daria Caraway. Thank you again.